Good morning, dear students. How are you all? So, dear student, this is a video of class 9, second video, and in this video, we will talk about the law of chemical combinations, second law, and that one is law of constant composition. Yes, sometimes this law of constant composition are also called as law of definite proportion. Why this is constant composition? Why this is definite composition, we will discuss about that one. Constant means that will never change. Okay, if you will take from any of the sources, that will remain constant. Definite means also the same thing would be there. So this law has been given by a scientist, and that one is Joseph Louis Proust in 1799. Okay na? And you can see here the definition is given that if I will consider about any of the pure chemical compound from any of the sources, every time that will combine with a definite composition. If suppose if I am talking about carbon and dioxide, carbon and oxygen, it will form one of the compound, that one is carbon dioxide. Carbon dioxide is actually forms from the carbon and oxygen, one carbon, two oxygen, and from wherever we will take, from whatever the sources we will take, it will contains the same thing. And if I will discuss about the water, then water, if I am talking about by mass, by volume, everywhere this water is a compound, and that compound, every time you will see that water is made up of two hydrogen, one oxygen. And if I will see by the ratio of mass, it will combine in 1 is to 8, sorry, 1 is to 8, here it is given. So yet again we will check about that definition. Pure chemical compound, it should be pure, it should be pure. Okay na? Carbon dioxide, H2O, NH3, these are pure chemical compound, will have definite composition. Yes, it has definite composition, or for definite proportion of the element independent of its source. What is the meaning of independent of its source? Means if I am taking water from sea, if I am taking water from river, if I am taking water from sewage, if I am taking water from any of the sources, it will have definite composition. Means everywhere water will form from the hydrogen and oxygen, two atom of hydrogen, one atom of oxygen. So this is the meaning of that one. This has been given by Joseph Louis Proust in 1799. And here you can see that pure water is given, constant composition is also written over there, hydrogen and oxygen. And we'll have the ratio, that one is hydrogen and oxygen, every time will be the same. If I will talk about carbon dioxide, sorry, if I will talk about carbon dioxide, every time this carbon dioxide, every from wherever we are talking about, in India, in Pakistan, everywhere, we will see and we will think that water, sorry, carbon dioxide is made up of the carbon and oxygen only. Okay na? So this is the thing you should know. Okay, carbon dioxide, carbon plus 2 oxygen. Okay, NH3, 1 nitrogen and 3 oxygen, irrespective of the sources from where we are talking about, independent of its sources. And also by ratio, that will be same everywhere. How this ratio we are actually finding, again we will talk about that one. As you know that H2O is what? H2O, what is the atomic mass of H hydrogen? 1 gram into 2. Again, 2 hydrogen is there. So what would be the resultant? 2 gram. Oxygen atomic mass is 16 gram. So if I have to find the ratio, gram will cancel out, 2 is to 16. and if I will write, this one will be cancel out, so it will give 1:8. Like this one, you can find the ratio of the atomic mass. Okay, now some of the questions we have taken from the law of conservation of mass also and law of constant proportion also. Here the first question I have taken, that one is the on the basis of law of conservation of mass. You can say that prove the law of conservation of mass when the mass of BaCl2, here mass of BaCl2 20.8, 14.2 Na2SO4, then it forms 23.3 gram and NaCl 11.7. So you should know this chemical reaction. If you know the chemical reaction, then easily you can do that one. Okay, so let me write once again. How will you write? BaCl2 plus Na2SO4, what it will form? It will form BaSO4 plus 2NaCl. Now you can see BaCl2 Na2SO4 weight has given, and what is the weight? Weight is 20.8, 14.2. So if you have to find the law of conservation of the mass, okay, now what will you do? Left hand side and right hand side. Okay, now left hand side and right hand side, that one is mass of reactant is equal to mass of product. Okay, now so mass of reactant, addition of mass of reactant and addition of mass of product should be equal, and if it is equal, then it is following law of conservation of mass, and hence you can see here it is given mass of reactant 20.8, 14.2, it will give 35 gram, and then after BaSO4 plus 2NaCl it will give 35 gram, and both are equal. Mass of reactant and mass of product are equal, and hence we can say that it will prove the law of conservation of mass. Okay, now one more question we will see. Calculate the mass of carbon dioxide released in the reaction. Calculate the mass of carbon dioxide. See, calculate the mass of carbon dioxide means carbon dioxide mass you have to find. So first of all, we will let it that mass of carbon dioxide is x gram. Okay, now released in the reaction when 6.3 gram sodium bicarbonate is added to 15.0 gram of ethanoic acid solution and 18.0 gram of residue left behind. Okay, now residue left behind. So you know here it is given in the chemical reaction, you see sodium bicarbonate, ethanoic acid, sodium ethanoate, and you have to find this one carbon dioxide. So you will let x. Okay, na x gram. What is the mass of this sodium bicarbonate? 6.3 gram. What is the mass of this one? 15.0 gram. And this one is the mass of reactant, na? So 6.3 plus 15.0. What it will give? 21.3. And mass of product is the addition of sodium ethanoate. That one is 18.0 gram plus x. Okay, na? So what it will give? It will give, together you will write 21.3 equal to 18.0 plus x. Okay, na? 21.3, let me just that one. Okay, so you can see 21.3 equal to 18.0 gram plus x. Should I move? Okay, here you can see 21.3 equal to 18.0 plus x gram. This will come in this side, 21.3 minus 18.0 equal to x gram. Okay, now what it will give? 3.3 gram equal to x. Okay, now equal to x it will give. Okay, so you can see 3.3 gram would be the answer. Okay, now so that is the thing you should know, that whenever some product or some reactant is not given in that question, you will take it, you will let it as x, and then after, what you have to do, you have to you have to find the value of x, and you can do easily. Okay, so these two questions were there. We will deal lots of questions in the class. Thank you, all of you. Take care of yourself. Thank you.